Thank you. Hello. Yes, so my name is Gleb, and today we will speak about Jenkins. So first of all, what will be my agenda today? I will start with a short overview of how generally a pipeline looks like, just to make the base ground. Then I will throw some topics. We will speak about how we maintain pipelines and what can be the obstacles and what we should avoid. I will talk about the Groovy language, because one cannot speak about Jenkins without speaking about Groovy. We will speak about Jenkins agents. Then, of course, also we must speak about Kubernetes, because you cannot do a talk without speaking about Kubernetes. And in the end, I will speak about Jenkins shared library and give you a short example. So let's dive in. I hope it will not surprise you that this is the main structure. Probably if you develop code, you have most of these steps, if not all. You start with checkouting, then you go to build, and the build step is basically when you take your code and you change it from being text to being Docker image or binary or anything you build from it. Then you perform tests. This is actually not a single stage. It's most of the time will be several stages. Maybe inside the test phase you will even have like internal loops of you recompile the code, you rebuild the environment, and etc. But let's keep it just for simplicity in one step. And in the end you deploy. And when I say deploy, the most basic thing may be create a tag for your code, but if you have binaries, move them to some different folder, release the binaries for customers, redeploy your application if you're deploying application and such. The same structure, but more prettier. The reason I'm showing you this is just to emphasize on the fact that those steps, the exact implementation may be very different, but it helps to fit them in those categories, because later your life will be easier. Okay, so we have this generic pipeline. So the first thing that helps us is that we categorized the different steps into these phases. And then what else we need to do? So first, it's important when we're maintaining a pipeline for a long time projects. So it will be easy to modify and easy to add or remove certain steps. Also, it will help you to find the bottlenecks, the current bottlenecks in your code. You will always have bottlenecks somewhere, but you want to have them in the place you want to have them. If your compilation takes you most time of your pipeline, probably something is wrong. Maybe you just don't have enough tests, but maybe you can optimize the compilation, and when you order those phases in an appropriate way, it will be easy for you to see it. Of course, you want to keep the changes such way that one branch will not bring the other branch. And when I speak about Jenkins, of course I mean the Jenkins file. And some stuff that we want to avoid when we use the pipeline. Of course, you want to avoid any debug prints. Not any debug prints, anything that helps you and shows you like the clear flow, put it there. But if it's not useful, keep it out. It will be just make your pipeline more messy when you would like to just like watch through it. Of course, avoid hard coding any configuration value. And last two things that you want to avoid as much as possible is duplications inside one pipeline. So most of the time you can avoid it with using functions. But if you have several projects, you also want to avoid duplications between your pipelines, between the different projects. And how you achieve that? With a shared library. So before we talk about the shared library, let's talk a little bit about Groovy language and why it is so good, or is it so? So what is Groovy? If you didn't hear about it, most of the people describe Groovy as Java without types. I'll give you some examples right now. The nice thing about Groovy is it gives you a lot of freedom. This is also the most awful thing about Groovy, because it gives you a lot of freedom and people should not have so much freedom. One of the coolest thing of Groovy is the G-string, which is a short for Groovy string, and that it just allows you to interpolate strings, and it just makes your life easier if you use it properly, and it will make your life hell if you want. And of course, you can have multiple ways of to call a function. So let's see some examples. For example, you can define a greeting as a string, but you can also use just def, and like Groovy don't care. And yes, so here you can see how we can just put the branch there and it will be fine. One thing that we need to be very careful, you cannot compare strings and G-strings. You must convert G-strings to string in order for it to be comparable as well as in the way you would expect it to compare. And of course, you can have several ways to call a function, which is nice because they give you a freedom. And if you have in your team, I don't know, some syntax that you prefer, go with that syntax. Just please keep it with same single syntax. Don't do one time without brackets, then with brackets, then let's do no. Keep it simple for yourself, and life, it will be easier for you to maintain it that way. Otherwise it will be hard. Okay, and of course, how this Groovy language helps us with pipelines. So basically, Jenkins supports the execution of Groovy. It compiles when you start the pipeline. And you will find most of the time that Groovy may be more useful than just using bash scripts, because it's more convenient, the loops are easy, you have more flexibility. When you have errors, the errors are more clear than in bash. It just will be more nice. Of course, the most important thing is not this language. The most important thing is that you will have pipeline where you have the control of what is happening. So you want the pipeline to be clear, and you want to understand easily when there are problems, where the problems are. So this is the main strength of Groovy. And of course, when you will create a shared library, this will be your language of choice, probably. Okay, and now let's talk a little bit about Jenkins agents. Previously, they were Jenkins slaves, and they were liberated, but not from all code. If you will try to write some code and use them, you will probably find in the code sometimes needs to access them as Jenkins slaves, but now they are agents. So two main types that I will talk about as the types of Jenkins agents. You have the permanent Jenkins agents, and you have the non-permanent. The problem with permanent Jenkins agents that they are permanent. So regarding scalability, usually, okay, it's in the end it's a physical machine, but if you are doing stuff right or more right, you will have it on a VM, and usually you will not dare to let the Jenkins agent execute more than one jobs at the same time. So basically you have a whole virtual machine, and when it works, only when you need to execute some job. Regarding maintenance, there is pretty high maintenance over time because software get updates pretty usually, and you need to constantly create some jobs, tasks to make sure that your software on those agents is what you really want to have. And another problem arises when you have multiple projects, and each project use resources or uses programs of different versions, then you are going to have a bad time. For example, and I will give examples later here regarding Maven. If you have some projects that use different versions of Maven or different versions of Java, you will need to have all those versions on the same virtual machine. Of course, as I mentioned it before, the resources when the VM is not used, wasted, and it's bad, sorry. And the most important part probably that it will cost you a lot, because you also want this agent to be pretty much resourceful, and especially when you have quite a few projects, probably you will have like a monster project, a huge one that needs a lot of resources to compile, then to test, etc. And then you have like a bunch of small projects. So you give the resources to match that monster project, and then each small project just wastes it and cannot use fully the whole machine. And why? So what we can do instead, we can use Cloud Jenkins agents. I'll give you then a few steps how to do it, but why it's good, it's easy to scale them. You just bring them up, bring them down as much as you need. If one of them is dead because, I don't know, it's stuck or something, it doesn't really matter, because in the end it's just a pod. So you kill the pod, you restart it, and everything fine. You have no problems with customizing them, because, as I said, it's a pod. You decide from what images it started. You just configure the proper images that will meet the expectations of your projects, like software and etc. And everything works. And of course, regarding the costs, you don't use resources when you're not using them, so you save here money. And so how Kubernetes connects to it? This is just a few simple steps how you configure it. You go manage Jenkins, configure the cloud. What is nice, it doesn't matter if your cloud is like a cluster, like in a real cloud, or you have a cloud on premises, because you just throw in a URL, you configure it, and you run. You can set a concurrency limit, just to, if you want to have better control over how much resources in the end your agents will consume, or how much instances of those agents will work. Maybe you want to limit developers so they will not work so fast, for example. And pretty much that's it. Later you can define pod templates, and this is the main like the main strength here of the cloud agents, because when you configure a pod template, you basically configure the whole setup of the agent, of all his parts, and then you do whatever you like inside that pod template. And this is just a simple example for such pod template. For example, like this is the basic example we have in our company. So we have the GNLP container. This is just the container that is responsible for communication between the pod and the server, and the Jenkins server. Actually, when you deploy, if you run your Jenkins server on the same cluster as the agent, you don't need it. But when you deploy the Jenkins on different cluster and the agents on different cluster, then you will need it. Maven, as I said, in our case, this is the container that will perform for me all the compilations. And then I have two builder containers. One builder, I use it for all the Helm related tasks. This is how I deploy, both for my tests and then later for production. And I have the builder because if I can create Docker images more effectively than with Docker, then why not? And what is nice is when I use in my projects the pod template, this is the basic pod template, but I can always add just another layers of more containers with more specific stuff. For example, several projects need Selenium. I can just add more containers based on this pod template. That's it. Everything will work. So, finished with Jenkins. Let's talk about our shared library and what we have inside. So we have the config class. Basically, it's like a data class that will have all the variables configured for us. Just all the configuration we store there, and then we can easily access it through the pipeline. Why it's good? Because then I don't need to care about variables to define them in several places. I just have this config instance that I create in the start of the pipeline and work with it for all the functions. And then I will have functions for each case. So I have all the Maven commands that cover most of my use cases. I'll have some commands for build, command for Docker images, commands for deploying Helm charts. Of course, I will have also some utils. Some of the utils I will use only internally. Some of the utils I will allow to use in the pipeline. And as I said before, I have also the pod template itself. So a little bit code examples. So this is how the config looks like. So yeah, just like name, version, some default stuff that I want to configure. And what is nice is that this allows me to create a pretty generic syntax for like to create a to save the boilerplate for each new project, because when new project will be created, they will also they will use the same variables, and they need very little to configure by themselves. And I can say, okay, just configure your project name, configure your version, configure your CI branch, and in what namespace you will deploy for CI, and that's it. All the other part you already have pre-configured. The side effect of that, by the way, if the projects follow also all the variables configured by the, for example, Helm chart folder and such, it allows us to move developers from one project to another project easily, because they understand the overall structure. They will not get lost. Maven, a nice example here is that, so here I kept only the basic call function. What it allows us to do, basically, I wrap the call to actual Maven by the Maven Groovy file, and then you can just call Maven, and then inside the quotes the command, and you get all the basic configuration you already receive, and you can add any additional variables that you need. It's pretty same thing about Helm. So here again we have the call functions, and then for example we have we create another useful function, a build chart. And why for example build chart is important for us, because first we will replace all the versions and all the tags with a pre-configured value. And what is done here on so basically here I'm calling this call function, so some like kind of recursion, you can say. But this is the example. Same way you call Maven. I just call it, and it will do the replacing, and then build and lint. Okay, so a couple of words about how one should maintain the shared library. My main point is to say that the shared library is just another code. The same way you treat the code of your project, you should treat the shared library. You should have branches, you should do a proper CR. It will be nice if there are versions. It will be nice if you will release. It will be very nice if you could also test the library and make sure that everything works. Of course, you need to document. My point is, it should be easy to use for whoever gonna use it. Another thing that I want to say here is that in my experience, problem comes when a lot of people try and add more code to the shared library. So try to avoid it. The purpose of this shared library is to make your pipeline more clear and more easy. If you try to overcomplicate it, if you try to add layers of abstractions and function that call function that have some class, some instances, some configuration, and if and that and switch and case, you are missing the point, because it might look nice and might look cool, but when you will try to debug why something doesn't work, it will be hard. And it will be even harder because most of the time the shared library is just code that works. And the point is that you want to deal only with the Jenkins file and just use it as some like external resource. It has a simple API, use it, it works, and it should have no problem. And the way to avoid problem in shared library, to keep it simple as much as possible. Okay, so let's go through an example of a Jenkins file. I tried to keep it as simple as possible, but we'll have like several layers. So what I do, I have like example project name, I have a repo for it, I set the name for the chart, etc. Send some configure the timeout. Here I use my library, and as I said, I save to config the instance of that config class. What will happen now, each time I update the config here, it will update the config instance, and because of the way the config class was defined as a singleton, when I update it here, it's also updated in all the calls inside all of the Groovy functions inside the shared library, because the instance of a class is a singleton. Okay, so I start here. I'm starting the actual pipeline, and before I start, what I do, I just config. We have like I didn't talk about it, but we have a function that creates for us a label. So I have the label, and I set up my pod template. And let's start. So what I have here, from here on I just try executing steps. So it's exactly the steps we were talking about in the beginning. I check out the code, I start with some unit tests, I then build the application, then I prepare I prepare the Helm charts, I build the Docker images, and if everything until now was nice, let's go. I mean, here I just omitted the integration test part just to make it more short, but you can imagine that somewhere between here and there is like a lot of integration tests, and they do cool stuff. But in the end, we do some code analysis, and if everything went fine, we are ready to deploy. So and another thing is, of course, this whole I'll go one slide back. What I did here, I'm wrapping all the code to everything that is executed, in my case, in try except. And why is that? Because I want to catch the error, catch the failure, and perform the finally step. And what I have finally, it doesn't matter if the pipeline succeeded or not. I still want to collect all the artifacts that I can, and in the end return the result to the developer. That's it, I think. Yeah.